In this video, we will learn Laplace Transform. Okay, Laplace Transform is an important technique which can be used to solve differential equation. For a given function ft, its Laplace transform has been defined like this. This is a L, okay. Ft has been defined as an improper integral from 0 to infinity ft e to the negative st dt. Okay. So Laplace transform has been defined as an improper integral. Okay. For given s, then you got an integral. You integrate that, you got a number. For given another s, you will get another number. So Laplace transform is a function of s. Okay. All right. So let's have a quick review about what is the improper integral. A to infinity ft dt. This is the improper integral, has been defined as small a to capital A, ft dt. Then you take a limit, let a go to infinity. Okay, from small a to capital A, this is a proper integral, which we are familiar with. So after you integrate this, you got a function of a, then you let a go to infinity. If this limit exists, we say this improper integral converges. Otherwise, we say this improper integral diverges. Now, before we find the improper integral, we need to know the limit of some important functions. For example, e to the negative t, e to the t. If t go to infinity, well, this limit goes. E to the t is a function like this. T here, e to the t. When t go to infinity, this is e to the t. When t go to infinity, get bigger and bigger, your e to the t get bigger and bigger, go to infinity. Okay, on the other hand, e to the negative t, what's the limit of that if t go to infinity? This is like t go to infinity. E to the negative t is 1 over e to the t. Your denominator getting bigger and bigger when t go to infinity. Your whole thing is getting smaller and smaller, go to 0. Okay. So remember the limit of those two things. Okay, now let's look at some examples. For what kind improper integral it converges, what kind it diverges. Now let's look at this one. 0 to infinity, e to the negative t. Okay, by definition, this one is equal to limit a go to infinity, 0 to a, e to the negative t, dt. Okay, so this one is a proper integral. Let's integrate that. Integrate this one, you got the negative e to the negative t, and evaluate at 0 and a, which give you limit a go to infinity. When you replace t by a, that give you negative e to the negative a. Then minus negative e to the 0. Okay, remember, e to the negative a go to infinity. This one go to 0 because of this. So the result, the first one give you 0, the negative one, e to the 0 give you 1. Negative, negative give you positive 1. So this limit exists, then equal to 1. So this improper integral exists. Now let's look at another one. The function we try to integrate it here is 1 dt. This is infinity. Okay, we have another improper integral. By definition, this you got a go to infinity. 0 to a dt. Okay. So give you limit a go to infinity. Then you got a t evaluated 0 and a. So give you a go to infinity. Replace t by a, give you a minus 0. A go to infinity, this go to infinity. So this limit diverges. Therefore, this improper integral diverges. Okay. We should know that the result is obvious. Okay. Now, this one this integral give you the area under the curve. The curve here is 1, which is this function. So 0 to infinity give you this area, which is obviously infinity. Okay, so now let's go back to Laplace transform. Okay. Laplace transform of a function ft has been defined as an improper integral. Ft e to the negative st. Okay. So for this improper integral converge, we know this function cannot be like this, should go to 0. Okay. Since the second one, e to the negative st, go to 0 very fast. So for most function we know, ft, for example, ft is t, this improper integral converges. For most of function, their Laplace transform exists. Okay, now let's look at some examples. How do we find a Laplace transform? The first example, say ft here equal to 1. In other words, we want to find a Laplace transform for ft, which is 1 here. Okay. When you learn math, everything is a definition. Okay. So let's see what is by definition, Laplace transform of ft equal to 1 is like defined as an improper integral. Replace your ft here by 1. 1 times e to the negative st dt. Okay. This improper integral by definition is equal to limit a go to infinity, 0 to a, e to the negative st dt. To integrate this one, this is a proper integral. Okay. To integrate this one, you got a go to infinity. Okay. Then give you negative 1 over s, e to the negative st, evaluated 0 and a. Okay. And it gives you limit a go to infinity. Replace t by a. So give you negative 1 over s, e to the negative sa. Okay, I want to say that s here is positive. Okay. Otherwise, this improper integral will not converge. Okay, so then subtract negative 1 over s, replace t by 0. Okay. Let a go to infinity. S is positive. We know this thing go to 0. Therefore, give you 1 over s. Okay. So what that means? That means Laplace transform of 1. This simplest function equal to 1 over s. That's what I said. The Laplace transform of ft give you function of s. Okay, now let's look at another example. Okay. Let me put Laplace transform definition here. Everything is about the definition. With s is positive. Okay. Now, next example is ft here is equal to e to the at. What do we want to do? We want to find Laplace transform of e to the at. By definition, Laplace transform of e to the at is equal to 0 to infinity e to the at times e to the negative st dt, which is e to the a minus s whole sinus t dt. Here, s must be bigger than a. Otherwise, if a is bigger than s, then if a is bigger than s, then the function will try to integrate like that. The area under that curve will give you infinity, it's diverge. That's why we ask s is bigger than a, so you got a negative component. Okay, now let's integrate this. By definition, this is limit a go to infinity, 0 to a, then become to a proper integral. Okay. A minus s t dt, which is a go to infinity. This gives you 1 over a minus s e to the a minus s t, evaluate 0 and a. Okay, so this gives you, remember, s is bigger than a, so this gives you negative something times t. Limit a go to infinity. 1 over a minus s e to the a minus s a, subtract e to the 0. Okay, since a is less than s, so this is e to the negative a go to infinity, this thing go to 0. So that gives us negative 1 over a minus s, which is s minus a. So what that means? That means Laplace transform of e to the at is a function of s like that, 1 over s minus a. Okay, let's look at one more example. This example, ft is like this. ft equal to 1 if t is between 0 and 1. 0 and 1. If t equal to 1, they equal to k. If t is bigger than 1, they give you 0. Okay, this function looks like this. Here's a t. Say here's 1. Okay, when t between 0 and 1, they give you, say 1 here. It's an empty dot. 1t equal to 1, they equal to k. Say, for example, k is here. 1t is bigger than 1, they give you 0. Okay. So whenever you give me t, I tell you ft. Okay. Now, we want to find the Laplace transform for such a function. So, by definition, Laplace transform of it, integral 0 to improper integral, 0 to infinity. Ft here, e to the negative st. Okay. Okay, for this example, for different t, your ft equal to different things. Okay. So, then we need to, okay, sometimes ft equal to 1, sometimes equal to 0. So we need to break our interval to several ones. So 0 to 1, right? ft e to the negative st dt, then plus 1 to infinity. ft e to the negative st dt. Okay. Here, when t here in this integral, t is between 0 and 1. Therefore, I can replace ft here by 1, e to the negative st dt. Okay, in the second integral, that means my t here is between 1 and infinity. So ft here is equal to 0 dt. So this one is 0. You integrate 0. Okay, that means you're looking for area under the 0. You got a 0. Okay, the area is 0. So we just need to integrate this one. So this one here is equal to negative 1 over s e to the negative st. You know how to integrate this one. Okay. Then evaluate 0 and 1. Okay. Replace t by 1. You got negative 1 over s e to the negative s, then minus negative 1 over s e to replace t by 0. You got this. Okay. So, negative, you got this 1 over s minus 1 over s e to the negative s. So, you can simplify that 1 minus e to the negative s. So, what is that? That is a Laplace transform of ft. This ft here is this one. Okay, now let's summarize what we learned in this video. Okay, so if you give me ft to find its Laplace transform, what do you need to do? Just do this improper integral. This improper integral may not always converge. However, since this one, s here is a positive, if t go to infinity, this one go to 0 very fast. Therefore, for most of ft, the function you are familiar with, for example, cosine t, sine t, this improper integral converges. In other words, its Laplace transform exists. Okay. Alright, so what do you need to do to find the Laplace transform? If it exists, what do you need to do? Just integrate this improper integral.